So I'm what you'd call a computational material scientist. I create theories and then play out the physics of these theories on computers to try to understand the process of self-assembly. I've worked with consortia that are sponsored or co-sponsored by GM, ArcelorMittal, Dofasco, US Steel. Most recently, I've engaged in a collaboration with IBM Bromont to look at interconnects of packaging. And all areas of our economy require something to be made out of, whether it's talking about aircraft, automobiles, bridges, buildings, concrete, you name it, there's always a material accompanying that process in our society. So understanding how the material is processed and structured will influence how it will perform in the real world. And this is an industrially very big issue because anything related to manufacturing, product development has that as one of its words. Compute Canada has been playing a vital role in providing most of the cycles and storage for my work, for my students' work, and we're playing a facilitating role in helping my students optimize code, get it to work on new technologies. That way I'm allowed to focus on the science, and Compute Canada can play the supporting role of how to use the infrastructure. In terms of teaching about what HPC is, how to use HPC, how to integrate it into one's individual research as an enabling tool. So in that sense, there would be a very large value-added benefit of an investment into something like Compute Canada, because then it can be turned into a tool by which you improve the time to market and the efficiency of materials and products. It creates jobs for people in a very high-tech environment, which is something that's quite important because more and more people are getting educated to have quite a lot of high-level education, so it allows an economy that takes advantage of advanced computing to create manufacturing in a virtual sense. So we're really talking about cutting down on the cost of development, saving dollars in terms of real development by making the development virtual first and then making it real. In the high-tech vision I'm proposing, where people are creating, let's call it like virtual manufacturing, you're saving bucks, creating jobs in high-tech development sectors, and saving tax dollars.